Hello viewers, welcome to Unacademy. Hello viewers, welcome to Unacademy Plus course. Unacademy is the #1 online platform coaching and teaching in India. I welcome all the viewers, those who are preparing for Karnataka CET, JEE, NEET. Unacademy is the best platform for their preparation. So use my code R.Vetrivel live to subscribe Unacademy Plus course. Complete syllabus coverage will be taken care. It is an affordable price. Have a trial plan at least for a month. Use my code R.Vetrivel live to subscribe Unacademy. Today we are going to discuss transmission of heat. The important concept of transmission of heat, thermal expansion. As we all know, whenever we supply the heat, the substance expand on lengthwise, area-wise and volume-wise. So the quantity of heat supplied, if I take a length of the rod, Q is the heat supplied. The quantity of heat supplied is directly proportional to original length of the conductor. Right? So, thermal expansion. Let us see that the important formula for thermal expansion. First, linear expansion. Thermal expansion of a rod. If the rod of length, initial length L0, after supplying heat, the increase in length or the change in length is delta L. The increase in length is directly proportional to initial length. The increase in length is directly proportional to rise in temperature. Combine both. When you combine this, increase in length is directly proportional to L0 into rise in temperature. When you make equals this proportionality, we need to write a constant. So L0 alpha delta T, where alpha is coefficient of linear expansion. Right. So this original length of the rod equal initial length plus increase in length. We know already increase in length. See here, increase in length delta L equal to L0 alpha delta T. Substitute, you will get L equal to L0 into 1 plus alpha delta T. Coefficient of linear expansion alpha, that is lengthwise expansion. Now area-wise expansion or areal expansion. See that the body, right, when we supply the heat, the quantity of heat, area-wise, the square plate I have taken, supply the heat, all the side, area-wise it expands, right. Suppose the initial surface area A0, right, and after heat supply, the increase in area delta A, right. Similarly, we know that the quantity of heat supplied is directly proportional to initial surface area. Quantity of heat supplied is directly proportional to, right, increase in area, right. So this is rise in temperature. So combine all. you will get increase in area equal initial area into, see that when you combine this, we will get initial area into rise in temperature. So Q equals A naught beta into delta T, where beta is areal expansion. That meaning this is coefficient of areal expansion beta. Previous one length expansion, that is alpha. This is coefficient of areal expansion. Right? Good evening all. Right, Rohit? Now can you hear me? Kacheri Gowda? Right? And now audible? Okay. Now this is volume expansion. When a metal rod is heated, its area is expanding. So here beta is the coefficient of areal expansion. Right? From here, see that beta equals increase in area by original area into rise in temperature. And in previous one, alpha equal to coefficient of linear expansion equal to increase in length by original length into rise in temperature. Alpha is coefficient of linear expansion. Beta is coefficient of areal expansion. Now let us see volume expansion. Suppose a cubical box is heated. Its length, area, what is happen, volume wise it will expand. Length, breadth, height, all the side it will expand. Right? So initial volume V naught, right? So the quantity of heat supplied is directly proportional to initial volume. Quantity of heat supplied is increase in temperature. Combine both, you will get V naught into delta T, that is equal V naught gamma into delta T, where gamma equal, right, increase in volume by original volume into rise in temperature. This quantity of heat supplied is nothing but here change in volume. So the increase in volume is directly proportional to original volume. Increase in volume directly proportional to rise in temperature. Combine these two, then only you will get increase in volume equal V naught gamma into T, where gamma equal increase in volume by original volume into rise in temperature. So this relation keep in mind. The same way here the quantity of heat, what I said, these are all increase in area directly proportional to original area. Increase in area is directly proportional to rise in temperature. Combine these two, increase in area is equal to, right, beta into delta T. So beta equal increase in area by original area into rise in temperature. So alpha, beta, gamma, what is the relation? We all know 1:2:3. So alpha by 1 equal beta by 2 equals gamma by 3. So we know that beta equals twice alpha, gamma equals thrice alpha. This relation keep in mind. Now let us move to, right, important problem. Before that, keep in mind coefficient of linear expansion alpha. Coefficient of linear expansion equal increase in length by original length into rise in temperature. Next one, coefficient of superficial expansion, areal expansion, beta equal increase in area by original area into rise in temperature. Cubical expansion, that means volume expansion. Volume expansion denoted by gamma equal increase in volume by original volume into rise in temperature. So we all know specific heat at constant pressure Cp, specific heat at constant volume Cv. The relation between these two, Cp minus Cv equal to R. This is called Mayer equation. Cp minus Cv equal to R, where Cp is specific heat at constant pressure, Cv specific heat at constant volume. So Cp minus Cv equal to R. This is called Mayer equation. Mayer equation or Mayer relation. Cp specific heat at constant volume always greater than Cv. Specific heat at constant pressure is greater than specific heat at constant volume. The ratio of Cp by Cv, specific heat at constant pressure to the specific heat at constant volume, is equal to gamma, ratio of two specific heat. This gamma value generally 1.4. So the ratio of two specific heat, Cp by Cv equal to gamma. Keep in mind. Now we all know that the amount of heat required to change the temperature of the solid of mass through the quantity of heat required is directly proportional to mass. More mass, more heat we need to supply. The quantity of heat supplied is directly proportional to rise in temperature. If we increase the temperature, more heat will produce, right? That means if we raise the heat, more temperature will rise. So heat is the cause, temperature is the effect. Combine these two, heat, quantity of heat supplied is directly proportional to mass and rise in temperature. Make equal mc delta T, where C is specific heat, right? Specific heat. From this C equal Q, quantity of heat supplied by M into delta T. Specific heat formula, that's only given here. Q equal mc delta T, where C is specific heat, SI unit of specific heat, joule per kilogram per Kelvin. Heat capacity means product of mass into specific heat. Heat capacity is different, specific heat is different. Specific heat C equal to Q by M delta T. Keep in mind this formula. Now, see that a metal rod is fixed at both the ends with the rigid support, right? You can see here, right? Kamalesha, welcome. If a metal rod fixed at both the ends, see here, both ends are fixed. Now you supply the heat, right? Now what happened? Lengthwise it cannot extend now because both end is fixed. Now heat we are supplying heated, then the thermal expansion it exerts a force on either side, length of the rod L, right? So now on the rigid support, whenever we supply the heat, right, it exerts force on rigid support. So the force is nothing but here tensional force. The tensional force is Ya alpha delta theta. Keep in mind, Y is Young modulus. Here we know Young modulus, we all know that stress by strain, right? Young modulus is stress by strain. Stress is force by area. Strain is increase in length by original length. So you will get this formula we know. F by A into L by delta L. Delta L increase in length we know that L into alpha delta T. So we will get finally the force on a rigid support is Ya alpha delta T. Y Young modulus, area of cross section A, alpha coefficient of linear expansion, delta T, change in or rise in temperature. So keep this in mind. Let us proceed to write the last one. The amount of heat required to rise the temperature of n moles of solid through temperature delta T is. So keep in mind Q equal, see, suppose n moles of solid we are heating through delta T, then it will be Nc delta T. We know first specific heat we discussed, Q equal mc delta T, where C is specific heat, here mass, here number of moles given mean use this formula, quantity of heat required equal to rise 1 moles of temperature or 5 moles of substance, N C delta T, keep in mind, N is number of moles, right? So this have an idea. If suppose specific heat at constant pressure given means Cp delta T, quantity of heat required for n moles of substance in specific heat at constant volume means Cv, use it, right? So this formula, remember, Unacademy, already the free practice daily test is going on. It is free absolutely. Attempt the test for free, right? Here is the first question, right? Here is the first question now. A brass rod of length 1 meter long and heated through 80 degrees Celsius, right? Increases the length by 1.60 mm. The coefficient of linear expansion for the brass is, right? Coefficient of linear expansion, right? Original length is given, understand? So 1.60 mm, it is increase in length also given, temperature is given, coefficient of linear expansion, alpha is the question. We all know coefficient of linear expansion, alpha equal increase in length by original length into rise in temperature, right? Now you can substitute all the values is given, right? So increase in length, it is given 1.60 millimeter is given. So millimeter given, you convert into, right, meter, clear? So the millimeter is given, so 1.60 into 10 power minus 3 millimeter, convert into meter, divide by 1000 into original length. Original length is 1 meter. 1 into rise in temperature, it is 80 degree. Simplify, you will get 0.0002 per degree Celsius. So option A is correct answer, right? Coefficient of linear expansion, easily you can do that, directly formula use it. Absolute correct answer is first one. Let us go for the next one. Now, a steel wire uniform area, so area of cross section given clearly, is heated up to 50 degrees Celsius. So the temperature is given, heated up to, stretched by the tying its one end rigidly. That means a rod is tying at one end fixed. The change in tension when the temperature falls from 50 degree to 30 degree C. See, the rod is fixed. Area of cross section of the rod is given. Temperature difference is given. Young modulus is given. And coefficient of linear expansion is given. What is the question? Change in tension. Tension is nothing but force. The rod is fixed at both the end. Then we know that formula. Tensional force is nothing but F only. Tension. Change in tension is nothing but F equal. See, Young modulus given, area of cross section given. This concept just now we discussed. We know that formula F equal Y A alpha into delta T. That's it. This is tensional force. Y, Young modulus is given 2 into 10 power 11 into area of cross section is given 2 millimeter, right? So millimeter square convert into meter square, 10 power minus 6. into alpha is given 1.1 into 10 power minus 5 into rise in temperature final minus initial 50 minus 30. That's it. Simplify all the values given. Simplify. You will get tensional forces 88 Newton is the correct answer. Have you checked it? Right? Direct formula. Substitute all the values given. Young modulus, coefficient of linear expansion, area cross section, rise in temperature is given. Substitute all. You will get correct option. Yes. Let us move to right. Next one. Right. Now Rohit Anban, can you hear the voice properly now? Okay. So next one. A rectangular block is heated from 0 degree Celsius to 100 degree Celsius. Rectangular block. The percentage increase in its length is 0.2%. The percentage increase in its volume. So how much percentage volume increase is the question. Rectangular block heated from 0 to 100 degrees Celsius. We know volume is L cube. Rectangular side is L. So volume will be side cube, L cube. So now this go for change in volume by original volume into 100 because percentage they ask. We know that volume equal to L cube. So change in volume by original volume equal L cube, right? L cube, take the differentiation now. 3 into L cube, 3 will come N cube, N into N power minus 1. Do that now, right? L cube, 3 into change in length by original length into 100. That's it. Equal 3 into what is the change in length by original length? How much is change in length? See, percentage increase in length is given 0.2. So, change in length by original length. That meaning percentage increase in length is given 0.2. Multiply, you will get 0.6 percentage. Right, that is the percentage increase in volume. Let us move to the next question. Right? Here it is. The volume of a liquid is 830 cubic meter at 30 degrees Celsius and it is 850 cubic meter at 90 degrees Celsius. The coefficient of volume expansion of the liquid, right? See, volume of the liquid is given at 30 degree and 850 meter cube volume at 90 degrees Celsius. Coefficient of volume expansion we all know gamma equal coefficient of volume expansion equal change in volume or increase in volume by original volume into rise in temperature, right? So what is the change in volume? Final volume minus initial volume. 850 minus 830. Right? Change in volume by original volume. Original volume will be 830 into increase in temperature, rise in temperature 90 degree minus 30 degree. That's it. Simplify. You will get 4 into 10 power minus 4 per degree Celsius is the correct answer. So option C is correct one. Check it. Calorimeters are made up of which of the following? We all know calorimeter is a device used to measure the quantity of heat. Calorimeter is generally made up of copper. Copper is a metal. Why? We all know heat always, right? Heat lost equal to heat gained. So metal is the quickly absorb or transfer the heat. So calorimeter is made up of metal is the correct answer. We know heat lost equal to heat gained. Right? Calorimeter is the device used to measure quantity of heat. Glass, no. Wood, no. Either, no. It is purely metal. Generally calorimeters in laboratory is made up of copper. Let us go for next one. in order that heat flows from one part of the solid to another, what is required? If a heat want to flow from one part of the solid into another part, what is required here? See, uniform density, density gradient, uniform temperature, temperature gradient. So keep this carefully in mind. Heat always flow from higher temperature body to lower temperature body, right? Heat always flow from higher temperature to lower temperature body. The temperature gradient, that's the meaning. Temperature gradient means temperature difference with respect to length. Temperature difference with respect to length. That is required for the heat to flow from one part of the solid into another part. So, dt by dl or dt by dr, temperature gradient is necessary. Right? In order heat to flow from one part of the solid to another, what is required among this? Temperature gradient is required. Keep in mind. So, temperature gradient is required. That is the correct answer. Right? Next one. 540 gram of ice at 0 degree Celsius is mixed with 540 gram of water at 80 degree Celsius. The final temperature of the mixer is, see that, mass of ice at 0 degree Celsius is mixed with 540 gram of water at 80 degree Celsius. Understand? Right? How much heat required to melt 540 gram of ice at 0 degree Celsius? We know that Q equal to M into L. Right? So, latent heat of ice 80 calories. Keep in mind. So here 540 gram of ice at 0 degree Celsius is mixed with 540 gram of water at 80 degree Celsius. So, the heat required, keep in mind, the heat required to melt 540 gram of ice at 0 degree Celsius. How much quantity of heat required to melt 540 gram of ice at 0 degree? Right? Q equal to M into L. M 540 into latent heat of ice is 80 calories. Keep in mind. ml quantity of heat required to change the state. Right? Ice want to melt it. How much quantity of heat required to melt the ice at 0 degree Celsius? M into L. Mass 540 into 80 calories L, latent heat of ice. Now, the heat lost by, when it is mixed with 540 gram of water, then heat lost by 540 gram of water, right, in cooling from, the water is, where it is, cooling from 80 degree to 0 degree Celsius. See, water is already in 80 degree Celsius. If you mix it 540 gram of ice at 0 degree, then heat lost by 540 gram of water. Right? So, this M into L, here ml is 540 into latent heat of the same 80 calories. Now see that in both the cases, both are equal. Heat required to melt 540 gram of ice at 0 degree is equal to heat lost by 540 gram of water in cooling from 80 degree to 0 degree. ml same only, both are same. So the temperature, final temperature is 0. Since both are heat required to melt the ice, heat lost by water, both are equal. So the temperature will be 0 degree Celsius. D is the correct answer. Now, for a gas, right, see that for a gas, the difference between two principal specific heat is, difference between two principal specific heat, Cp and Cv, difference given. What is the specific heat of gas at constant volume? CV. Constant volume, right? If the ratio of specific heat is 1.4, ratio means we know that Cp by Cv, ratio between two specific heat is equal to gamma. We know that Mayer equation. Remember, Cp minus Cv equal to R. So here Cp by Cv, the ratio of specific heat is given 1.4. Therefore, gamma is 1.4 equal Cp by Cv, specific heat at constant pressure by specific heat at constant volume. Right? From this, Cp equal cross multiply 1.4 into Cv. Right? Now, first line see, the difference between the two specific heat is 4150 is given. So now, difference between two specific heat, Cp minus Cv equal to R. Right? So, what is Cp? 1.4 Cv minus Cv equal to R. How much is given? It is 4150. Now 1.4 minus 1. It is 0.4 Cv equal 4150. Now we want to find specific heat at constant volume equal 4150 by 0.4. Right? You will get 10375 joule per kilogram per Kelvin. Option second is correct answer. Right. Let us move to the next question. Here it is. Daily practice test is going on. It is absolutely free. So attempt the live. Right. It's the free one, daily 2020. Right. Go ahead. Now, if 70 calories, see that 70 calories of heat is required to rise the temperature of 2 moles of an ideal gas at constant pressure from 30 degree to 35 degree. Then the amount of heat required to rise the temperature of same gas through same temperature at constant volume. Right? So we know that quantity of heat required Q equal Ncp delta T. Remember, this is specific heat at constant pressure. From this, what is Cp specific heat at constant pressure? Q, quantity of heat required, Q by N into delta T. That's it. Now, what is the heat is given? 70 calories by N. 2 moles is given, right? So, 2 moles into rise in temperature. Right, 35 final temperature minus initial temperature is given equal, you will get 7 calories per mole, right, per degree Celsius. But we know that the difference Cp minus Cv equal to R, right? We know that Cp minus Cv equal to R. From that, what is Cv? Cv equal Cp minus R. That is given, see that, Cp minus R. So what is Cp here? Now bring it. So Cv equal Cp minus R. Specific heat at constant pressure. Right? 7 calories we got. 7 minus R. Here R is nothing but, right, 2. Right? 2 moles. So 2 equal to 5 calories per mole per degree Celsius. So specific heat required at constant volume is Q equal the same N Cv into delta T. We need to find, right, Q, quantity of heat required. What is N? Number of mole 2. What is Cv? Cv 5 into rise in temperature 35 minus 30 degree. That's it. Multiply, you will get 50 calories. Is the correct answer. Quantity of heat required is 50 calories will be the correct answer. Yes, let us go for the next one. Right? Here it is. Now, the quantity of heat required to change the unit mass of a solid substance in its liquid state while the temperature remain constant. See, temperature remain constant means latent heat. Change of state takes place. See here, how much heat required to change the unit mass solid into liquid without rise in temperature. So latent heat of fusion. Fusion only solid to liquid. Liquid to gas means vaporization. So D is the correct answer. 1 mole of an ideal gas required 207 joule of, right, to rise the temperature by 10 Kelvin when heated at constant pressure. If 1 mole of the same gas is heated at constant volume, right, to rise the temperature by 10 Kelvin, then how much heat required? Right? So keep in mind we need to use quantity of heat required equal, we all know, NCP into delta T. Right? Here quantity of heat is given 207 joule, heat is given Q, equal number of moles is given 1. Specific heat at constant pressure we need to find into rise in temperature is given 10 Kelvin. That's all. From here, specific heat at constant pressure you can find, right? You will get 207 by 10, that is 220.7 joule per mole per Kelvin you will get. CP, specific heat at constant pressure. We know Cp minus Cv equal to R. Cp is 20.7 we got now, minus Cv is given already. Specific heat at constant volume is given, see that. So we need to find Cv equal to R is given 8.3. So Cv equal 20.7 minus 8.3, nothing but, right. So 20 minus 8.3, you will get 12.4 joule per mole per Kelvin. Right? So we know that Q equal quantity of heat required equal NCV into delta T at specific heat at constant volume. So N is number of mole is given 1 into CV specific heat at constant volume. It is given already, right? 12.4 into rise in temperature 10. You will get 124 joule. So D is the correct answer. The railway lines are laid with the gap to allow for expansion. If the gap between the steel rail is given 66 meter long and 3.63 centimeter at 10 degrees Celsius, expansion given, then the temperature at which line touches coefficient of linear expansion of steel is given. When it will touches, so we know that in change in length equal original length into alpha into rise in temperature. We know that. From here, the increase in or change in temperature equal, right, change in length by original length into alpha. That's it. All the values given. Change in length is given 3.63 changes length, right? Centimeter given into minus 2 10 power. So that meter by L naught. Original is given 66 into alpha, coefficient of, right, steel is given 11 into 10 power minus 6. Simplify, you will get 50 degrees Celsius. But final temperature, see that the temperature at which line touch each other. So that initially the temperature is 10. Now final temperature equals that 50 plus 10, 60 degrees Celsius. It is the final temperature. Right? A hole is drilled in a copper sheet, right? Diameter of the hole is given, temperature is given. The change in diameter of the hole when the sheet is heated to 227 degrees Celsius. Coefficient of linear expansion is given, alpha is given. So we know that whenever the copper sheet is heated, the diameter of its hole also increases in the same manner in which the length of the rod increases. Right? So option D. Right? You will L is given. Right? You will get right same use it increase in length alpha equal increase in length by original length into rise in temperature. You do that, you will get it. Option D. Next, an iron tire is to be fitted on the wooden wheel. Diameter is given. The diameter of the tire is 5 mm smaller than the wheel. The temperature by which the iron tire is to be heated. Alpha is given. So diameter is given. So here increase in diameter equal, instead of length here diameter given. Increase in diameter equal to original diameter into alpha into rise in temperature. Use this. From this, increase in temperature equal change in diameter by original diameter into alpha. Change in diameter is given 0.5. Original diameter 100 minus 5 mm. Right? 5 mm I can write 0.5. Right? 100 centimeter. This is 5 mm. So you write it 100 minus 0.5. Mm convert into centimeter. Right? Into alpha value is given 12 into 10 power minus 6. You will get B option 418.8 is the correct answer. Have you check it? And next one, 100 gram of ice at minus 10 degrees Celsius is heated till it's converted into water at 30 degrees Celsius. The amount of heat required is latent heat of ice is given, specific heat of ice is given. So how much quantity of heat required to change from 100 gram of ice at 10 degrees Celsius to water at 30 degrees Celsius? First, what we have to do, how much quantity of heat required to change the ice from minus 10 degrees Celsius to 0 degrees Celsius. First, we have to do minus 10 degrees Celsius to 0 degrees Celsius. Here, ml, change of state, right? Quantity of heat required to change minus 10 degree to 0 degree Celsius, right? mc delta T. Then 0 degree ice to 0 degree water, ml, change of state. Again 0 degree to 30 degree, right? Liquid, mc delta T. So first Q1, quantity of heat required to change minus 10 degree Celsius to 0 degree Celsius ice. So mc delta T, use it, you will get 500 calories. Next Q2, from ice at 0 degree Celsius into water at 0 degree Celsius, ml, latent heat, use it. You will get here 8000 calories. And then next is how much heat required to change, now it become water. Water at 0 degree to water at 30 degree Celsius, mc delta T. Do that, you will get 3000 calories. Now total heat is Q1 plus Q2 plus Q3. Add all, you will get 11,500. Option D is the correct answer. Right? And which of the following has the highest specific heat? We know among the liquid it is water. But here gases given, hydrogen has the highest specific heat among the given one. Hydrogen specific heat 14300 joule per kilogram per Kelvin. So the liquid given mean water has highest specific heat among the liquid. But here solid, gases, everything is given. So hydrogen gas has the highest specific heat among all. So that's the end of today's session for transmission of heat. I hope you learned, right? Transmission of heat, a few basic problems. Let us see, and we will meet you again in the next YouTube class of Unacademy. Till then, myself Vetrivel, Unacademy Physics Educator, signing off from you all. Have a nice day. Thank you.